Okay, everybody, this is Don Wedding. This is homework number 2. This is the sync session for that. And then this is the summer session of Predict 411, July 2017. So I guess we're going to get started today. And the first question I think is, does anybody have any questions? One student asked me something before I hit the record button, and we'll address that in a minute, but does anybody else have any quick questions that we want to address, and then I'll make sure I talk about them as we go. I'm hearing silence here. Let's see, I'm going to draft somebody here. Allison Resner, you got a question for me? Let's see. I don't think Allison's got a question. Nope, I'm hearing silence there. Okay, how about Eric? You got a question for me? Can anybody hear me?
Yeah, I can hear you.
Yes.
I'm just getting this stunned silence on the other end. Okay, Chris, you're going to be my friend today because you're the only one who responds.
Great.
Okay, so what I'm going to do is I'm going to share my screen, I suppose. And I thought tonight, since I've already done the insurance problem quite a bit. In fact, if you watch the sync sessions here, I'm going to, just a moment, let me share my screen. Okay, so let me see. So you guys can see my screen. Is that correct? Well, maybe not.
No, it's out.
Okay. Let's try it again. You can see my mouse moving now?
Yes.
Oh, perfect. Okay, great. So what I'm going to do today is I thought maybe we could do the Moneyball problem instead. No, not the Moneyball problem, I'm sorry, the home equity line of credit problem. How about that? So this would be, and incidentally, you don't have to take copious notes because everything I do here I'm going to post. So you just pay attention and understand what I'm doing. So what I'm going to start off with, I've already this is something you've probably seen already 1,000 times. You know, I usually like to set up a macro variable for the path on where the file is. This is on my laptop, okay? So this path here is not going to be the same as you. Your data files are located somewhere else, but just put in where your data is located and you should be just fine. The rest of this should work just fine. So I'm going to set up this and run it, and what this is going to do is it's going to run a proc contents, and it's going to run a proc print of the first 10 records. See, contents is going to tell me the records, and this guy here is going to give me the first 10 to print them off. So let's run this guy, and there we have it. So this is to show you that we have 13 variables, and this is going to be for home equity line of credit. We're going to predict who's going to default on a loan, a home equity line of credit loan, and you can see that we've got 4,730 records, 4,730 records. We've got 14 variables here, and these are the variables. Now, what these mean, and there's a data dictionary here, but this is like credit line age. That's how many months you've had a credit card. CL number, this is how many credit cards you have. Debt to income ratio, the number of delinquencies. This means how many times were you late when you were paying your bills. Derogatory is how many times you just said, I'm not going to pay this bill. So derogatories are really bad. Delinquencies are kind of not good. Job, this is what job you have. What's the loan you have on your house? Mortgage due, that's how much money you still owe. Number of inquiries, that's how many times did you go out looking for credit cards. Typically, the rationale is that if you go out there and you keep asking people for credit cards, that's usually a bad sign. It means that you're running out of money because you keep saying, can I have can I borrow money from you, MasterCard? And that's bad. Reason for wanting a loan, the target, that's what we're going to try to predict. 1 will be the people who don't pay us back, and the zeros will be the people who do. This is the value of your house, and YOJ, that's years on job. So this is a bingo bonus problem. And what we're going to do is we're going to solve this, and it's going to be very similar to how we would solve the insurance problem, but it's sort of a simpler problem, and I just want to go through a lot of different things tonight with this. So I just printed off the first 10 records, and you can see a lot of the people who defaulted are at the top of the file. So the first 10 records, 9 of them, the people defaulted on the loans. And you can see that I've got some missing values here, so we're going to have to fix those. We've got some categorical data, like the reason why they want the loan. Is it for home improvement, debt consolidation, or something else? The job, office worker, other. We'll see what kind of jobs they have. So this is the data set that we have. So does anybody have any questions before we get started? We're going to try to solve this and build ourselves a predictive model. So anybody want to type in or hop on the phone and scream out a question? Please don't be shy. This is office hours here.
Can you will you be doing a decision tree in your?
Not on this one, I won't. But let me think here. What could we do? I do cover, just give me 1 second here. I'm going to stop sharing for just a moment. I want to log into the course shell, and I just want to make sure that, because I'll show you something here just a moment. Okay, just didn't want any sensitive material to be up on the screen. Got a couple of questions here. I'm sorry, but what was number of inquiries? That's the number of NINQ. That's the number of inquiries. That means that you're going out there and you're asking for credit cards. You're saying, can I please have some inquiring into getting a credit card? The more of those you have, usually the worse a person you are. Does that make sense, Andy? Okay, great. So let me see. Let me share my screen again. Great. Okay, so if you look on the course shell, I've got here recordings from the past, okay? So these were like, for example, if you click on this guy here, I've got a lot of stuff on previous office hours, and I even tell you what I covered. So I said, okay, I wrote some, simple logistic model, and I did, this one I did some, the damages part, where I try to figure out the damages. So I did a lot of these things. This one I solve it with Enterprise Miner. This one I did Enterprise Miner with decision trees, et cetera, et cetera. Okay, so this is what you can look at this, but if we go back a page and we do down here to, I think, one of these things I actually solve it, I believe, with, I used R for something. Let me see. Just give me one moment. Let me think. Maybe I didn't. I think that one of these things I might have actually used Rattle, R-A-T-T-L-E, the R package Rattle. I'm not sure where it is, but it's worth looking through these things real fast, because sometimes, people are like, well, gosh, did you solve it with R ever? And I'm like, well, I don't know. I think I did, but I may or may not have it posted, or it might have been for like a wine problem or something. So these things are worth looking at. Go out there and poke around in these things. There's a lot of good information. So I'm not going to be messing with R tonight, and I don't think I'll do anything with the decision tree. But if I have time, I'll try to get to it. But I'm hitting up against the other class is going to be following along real soon. So whoever asked that, did I help at all, or was that not really very useful to you?
Yes, I think I saw the decision tree, the R stuff. It was like the 2016
Okay.
September class. It looked like on that page.
Okay, if I did that, that's where you would want to see that, because Rattle is a real good package if you want to use some decision trees real fast. Okay, so if I were to solve this problem, okay, so the first thing I always do is I usually do a proc contents and a proc print, okay? So now what would I do if I were to solve this problem, or really any type of problem, is the first thing I do is I look at the variables or the data. So I'll do something like, usually I do a proc means data. Well, okay, actually what I'm going to do is I usually make a copy of my data. That's why I create this temporary file. The reason why you want to create a copy of your file, there won't be a problem here because it's all write protected. But in the real world, it usually isn't. And if you screw up your data file, you're going to have problems. You're going to have to go get a new one. Sometimes it's not so easy to do that. The first thing I always do is I usually make a copy of my data set. So data, temp file, set, in file, run. And that does nothing more than just copies this guy right into temp file. So I just do this. So if I run this code, I'm going to end up with an exact copy of the other guy. So it's an exact copy. So now what are we going to do with this stuff? Okay, well, this is what I typically will do. The first thing I like to do is explore the data. So I might do something like run a proc means. Data equals temp file. And what I'm looking for is I'm looking for outliers, and I'm also going to look for missing values. Right off the bat, I like to look for missing values. Okay, so let's do this. Let's do proc means, let's do temp file, and I'm going to do nmiss, and that's going to be the number missing. And I'm also going to do, how about if I do the mean, and we'll just leave it at that. And then we'll do var, and if I do underscore numeric, underscore, that's going to have all of the numbers, the numeric values. I don't have to type them all in by hand. This is just going to use all of the numeric values. And there they are. So you can see I've got like, well, index, that's just their ID number. Target flag, that's what we're going to try to predict. But you can see the loan, and they got the mortgage due, the value. This is the average value here. And you can see I've got some missing values that I'm going to have to do something with them. Okay. So today, let's just pick like 2 or 3 variables. Oh, let's do one other thing too. Let's also look at the categorical variables. And you usually do that with a proc frequency. So I do a proc frequency. Data equals temp file, table, and I could type in job right here. And let's do that. Let's just do table, and then we'll do the other one, reason. So you can see that I've got here managers make up 13%, office workers are 16%, miscellaneous is 39%. So you can see I've got all of these people here. And then debt consolidation, home improvement, and I also have this guy right there. So I have some categorical variables, and I also have some continuous. So what I was thinking let's do is let's use the job. We'll use the person's job as a reason for, as an input variable. And let's choose 1 or 2 of these guys here. Let's use debt to income ratio I don't know, credit line age and years on job. We'll use those three. Okay. So the first thing you have to do before you do anything is you're going to have to fix your missing values. So to do that, and again, this is going to be the same technique that we did with Moneyball, but we're just going to do it with a different data set now. What I like to do is I make a copy of this. So let's say we're going to fix years on job. Okay, so we'll do years on job. What I like to do is I'll do something like this. I like to create a new variable called imputed years on job, and then what that is going to be is I never like to just fix years on job. Okay. You know, I don't want to say something like if missing years on job, then years on job equals, let's make it the average. We'll make it 9 years. I could do this, and this would fix the problem. See, watch this. Let's run this guy. And then if I do this, you can see it's going to be fixed. See, none of them are missing now. You don't want to do that in the real world. And the reason why is because you've now changed a variable here. This variable, if somebody pulls this data out of the data set, or out of a database, they expect it to look a certain way. They expect it to have missing values. You've just changed this thing, okay? And that's not a good idea. If you're going to change it, create a new variable and use that one instead. Even if it's just doing nothing other than fixing it, that's a good idea. Never, if you're going to change one of your input variables, create a new one instead. So what I'll do is I'm going to, instead of doing that, I'm going to say the imputed years on job is going to equal to the years on job. And then I can say if missing then do end, and then we'll say imputed years on job equals 9. So now what I've done is, if we run this guy, whoops, we run it again, you can see I've got years on job, whoops, you can see I've got years on job in its original format. I've got 400 missing values. However, I've got this imputed guy, so I've got one that's fixed. I can use it. He doesn't have anybody missing, okay? So that's kind of what you're going to want to do here. So we'll do drop the years on job. We don't need that now. So another thing that you want to do is you're going to want to create a flag variable. If you fix a variable, you're guessing. And sometimes the fact that it's missing is highly predictive. So I'll create a flag, and I like to call it M underscore years on job. And then I'm going to say that equals 0. It means I'm not going to fix it. And if it's missing and I do fix it, then I'm going to say the M years on job is equal to 1. It means I fixed it. It means so now if we run this guy, about 8% of them were missing, and I fixed them. So we're going to use this as an input. Now, I think I've used this joke last time. I know I've used it before, but it's still funny, so I'm going to say it again. It's kind of like there's a Sherlock Holmes episode where the dog doesn't bark, and the reason why the dog didn't bark at the killer was because the dog knew the killer, because the guy who killed the killer was the guy who owned the dog. So that's why Sherlock Holmes knew that he was a the killer. So if you ever read, there's like, I think it's the curious incident of the dog or something like this. Turns out that the killer was the guy who owns the dog. So that's a spoiler alert. So that's my funny joke, you know, because I just told you the ending and then I did the spoiler alert. I do that to my kids all the time, and it really rubs them the wrong way because they're like, Dad, you got to say spoiler alert first. Like I don't know, but they don't know that I don't know. Anyways, so anyway, I've got this guy fixed. Let's do debt to income ratio. That's usually a pretty good one for this. So let's fix that guy. And people say, well, what do you do if you've got missing values? Debt, income. The best thing to do, I mean, the actual best way to fix a missing value is with decision trees. Okay, that tends to be the best way to go. Unfortunately, it's a very time-consuming process. So if you have something automatic like Enterprise Miner, that is a really great way of fixing a missing value. If you don't, fill it in with the average value. That's surprisingly, I know it sounds like very simple, but believe it or not, simple is sometimes very good. So, okay, the debt to income ratio is 33.7. We'll call it 34. So if I don't know your debt to income ratio, I'm going to assume it's 34. So let's run this guy, and let's drop the debt to income ratio. Drop. So there we go. So we got two variables. We've got the imputed years on job. We've got the debt to income ratio. And let's do another one. Let's do credit line age. So we'll do that, and then we'll grab ourselves a categorical variable. Let's see. I'm just pulling numbers out of thin air just to show you how I would solve this. Normally, I would explore this data a heck of a lot better than I am. I'm just showing you the techniques here. Okay, so let's see. The number of credit lines, 21. We'll call it 21. Let's run it one more time. And let's see if we got any missing values here. See, there it is. We've got these guys are all fixed, you know, the ones that we're going to use. So those are the guys we're going to work with. And loan doesn't have anybody missing, so we'll use him as well. So one other thing let's do, let me stop real quick and let's see, does anybody have any questions about what I've just done? Anybody?
No, that was pretty straightforward. Thanks.
Okay. Whoever that was, you're now my favorite student because you responded.
Don, I have a quick question. It's not regarding the code, but it's probably a simple question for you. In the results screen, how do you get that cumulative view of all of the output versus in my SAS? I've been messing with the preferences, but I can't figure out how to get a cumulative results output versus just a completely brand new output when I run a new code or a new line. Does that make sense?
I think, see, this is the PC version. My guy keeps just tacking it on, and every now and then I clear my window. I don't usually use the version you guys are using, so I don't know. I'd have to go in there and play with it and see what you're saying that every time you run it in SAS on demand for academics, it recreates the output window. Is that what you're saying?
That's correct. It erases everything prior to what you just ran.
I don't know how to turn that on and off. I'm sure there's an option, but I don't know what it is off of the top of my head. It always is like it's almost dependent on the installation of SAS that you're using. I'm sure there's a way to turn it on and off, but in my experience, I've been doing this for 10 years, and I just look at it. I take whatever the default is, and I just deal with it. And then, if it gives me new output every time, that's fine. If it doesn't, I don't particularly, never thought twice about it. I just deal with whatever it gives me. So the short answer is I'm sure there's an option. After this class, I'll poke around and see if I can find out what it is, but I don't know it off the top of my head.
That's fine. I'll ask around online. Thanks.
Okay. So one thing I'd like to do also is this. A neat little trick you can do to see what variable might be predictive is you can do this. Okay, we got this proc means here. Watch this. Proc means data equals temp file, and then we'll do mean. And number of decimal points equals 2 to make it look pretty. Now watch this. Class. Now, our target variable here is, what was our target variable? Is it called target flag? Target flag. Var numeric run. Now this is kind of cool. So if you're falling asleep, wake up. I'm about to show you something real cool. So I'm running this proc means here, but I'm going to put this class statement in. And remember, this guy's going to be a 1 or it's going to be a 0. So now what's going to happen is if I run this code, SAS gives me, he breaks it down this way. So he says, like, for example, loan. The loan for people who don't default, the good people, is 19,000. The people who do default, it's 16,000. That's a big difference. So maybe that's a predictive variable. Number of credit lines, 21. So people who default on a loan have 21 credit cards. People who don't default on a loan have 21 credit cards. So that one doesn't seem to be a big difference. Missing debt to income ratio. So in other words, if your debt to income ratio was missing, then if you're a good person, the number of missing debt to income ratio values was 10%. But if you're a bad guy, you don't pay me back, it's 65%. So you can see there's a huge difference there. Remember how I told you sometimes the fact that it's missing is highly predictive. In this case, it's the fact that the guy, if you don't have a debt to income ratio, it usually means you don't have a credit score, which means you might have changed your ID and you're committing fraud. But this is a great way of just running, and I'm about to make a funny SAS joke, so wake up because you're going to have to hear something funny. Proc eyeball. So you look proc eyeball, and you can just see what variables might be predictive and what might not be. Delinquencies, 1.25. Delinquencies, 0.25. So the delinquencies is predictive. So there's lots of predictive stuff here. Now let's talk about, let's say one of these categorical variables. Let's do the job. We noticed that some of the job values might have been missing. So let's say if we look over here, so some of the people, we don't know what your job was. So let's say that if we don't know your job, the most likely thing was other. How about that? So we'll say the imputed job equals job. If missing imputed job, then do imputed job equals other. Okay, there we go. And let's get rid of this guy here. Okay, so at this point, I think we got enough data to do something. We shouldn't have any, we'll have missing values, but we're only going to worry about some of these guys. We're going to use these guys right here, and then we're going to use the imputed job. Do I have any questions so far? I can't see the chat window, so did somebody ask a question? Any questions out there? Okay.
There's one that says, what about bad records? More than one variable is missing for one record?
Oh yeah, that could happen. I mean, some of these things, look, if you print off the first thing, some of these guys, look, print this guy right here. Record number 3, look at all the missing values I've got there. All I'm doing is fixing variables here. Did that, I mean, I'm sure I understood the question. Like, for example, the years on job was missing and I fixed it. But if you're going to use all of the variables, you got to fix all of them. Okay, what we're going to do is we're not going to fix them all because we don't have time. So I'm only going to fix some of the variables today. And we're only going to use the variables that we fixed. Did I help you?
Hey Don, when you declare m underscore job, it should be 0. I think you declared it as 1.
Let me see. Oh, you are right. That was a test, and you passed it. Good catch there. I just wanted to see if you guys were going to catch that. I'm making a joke there, guys. So let's run this guy again. Okay. So anyways, let's start running. So how I would normally analyze this data is I have this class variable here, and the other one you might want to do is do something like this. Proc frequency data equals temp file, and you can do table, and then you could do target flag star imputed job missing run, and then this thing will break it down by. Then you can see here that, for example, 13% of the people are managers, and you really got to look at the third row here. It's 15 and 12, not a big deal. 17 and 10. Apparently, office worker, maybe that's predictive. Other, I got 47 and 43. Maybe that's not a big deal. But when you get down here to sales workers and self-employed, yeah, I'm not sure if job is all that predictive. I mean, maybe it's not a predictive variable, but we'll use it. We'll see what we got there. Now, the next thing we're going to do is we're going to run the proc logistic, and I have some code from a previous class that I'm just going to pull it out here because I don't like to remember all of the syntax. So I'm pulling this guy out. So we can do proc logistic, and we'll do temp file. And then what we're going to do is if we're going to use a class variable like the job, you got to declare it up there at the top. You got to say class, and then you got to tell SAS that this is a class variable. And then you put parameter reference, and then so then we just simply type in all of the variables that we're going to have. But what we're just going to do here is the years on job, or the years on job, we'll use him. And then we'll use the M value. Then we'll do impute, whoops, well, let's just type them in by hand. Imputed job, M, job. Then we'll do the imputed debt to income ratio. Then we'll do, what was the other one we used? Credit line age? No, number of credit line, that's it. M, or imputed CL number, M, CL number, and then loan didn't have anybody missing, so we'll throw him in there. So what we're going to do is we're going to run, and somebody asked about a forward selection, so we'll use forward selection for this guy. Now, in a real world, I would be looking at all of the variables. I might throw away variables that have lots of them missing, but or have absolutely nothing to do with the target. I might throw them away to save time. But for the most part, I'll look at this and I'll have a big long list of variables here. And there's ways to use macros for this, but we're just going to do it old school right now and just type it in by hand. But I'm going to run a proc logistic. Here's our variables. We're going to create ourselves a rock curve. And then we're going to score this guy. And we're going to create a data file called Fred, and we're with the score value in it. So there we go. So if you look at the output of this guy, it goes step by step, and it tells you all the variables that it puts into the model. This guy put in, M job entered, and and this was the AIC, and then he put in the M credit line number, and this is the AIC. So he kept adding new variables into the model, and eventually this is what we got. We have these variables. The only one that didn't seem to make it into the model, I think, was the loan. So we have the intercept, and then the imputed jobs, and all of these guys here. So they all made it into the model. Now, somebody was asking me, how do you know which one the best one is? Well, the best one is for a forward selection it's the last one is what SAS considers to be the best. If you don't like something that went into the model, you can just take it out. So let's say that you're looking at this and you decide that you don't really want to put the credit line number or this guy in there. You could take him out and get rid of your forward selection too. You don't even have to do that anymore. So you can hard code in. You don't have to do one of these selections. You can look at the output of this guy and decide what you want, and then you hard code it in and get rid of your selection. So then you could do this. And then he'll give you just this guy right here. Well, let's take loan out of there too. So I'm not sure who asked that question, but did I answer your question? Let me ask you that question. Who asked that before the sync session started about the forward selection? Did that answer your question? And if it didn't, you got to let me know. What did he say? I can't read the chat window.
He said yes, you did.
Okay, perfect. Okay. Incidentally, the code that I'm providing here also has the way of generating a ROC curve. So this is a great way to do a ROC curve as well. So anyways, this is, this has now built a model. Now the next thing that we're going to do is you're going to notice that I put in this little piece of code here, score data out equals Fred. Why did I do that? Proc print data equals Fred, observation equals 10, run. If you put that little line there, he's going to score Fred. And look, he appends a probability score. Now, why are we doing that? I'll show you why in a second. The last thing you got to do, and I know we're running up against the time here, we got 15 minutes. The last thing you do is you got to create a score program. Remember that? So the way you do a score program is pretty simple. Data, score, and then let's do set Fred. Remember, Fred is going to be exactly, all Fred is he's temp, this guy right here, but he also happens to have those p-values on them, the probabilities. We're going to use this guy to test to see if our score program is correct. So when you write a score program, the first thing you're going to do is you go up here and everything you did to the data set before you ever ran Proc Logistic, you got to copy that into your score program. So if we get new data, we have to fix it. Now, we've already fixed the data. Ooh, you know what I just thought of? We dropped all those variables, didn't we? Let's undrop those variables. There we go. Don't worry about what I just did, folks. Just pay no attention to the man behind the curtain. And then we come over here and let's run this again. Okay, there we go. So now I've got those probability scores. And now we're going to score Fred. Now Fred is going to have those probability values. The first thing we're going to do is we're going to fix the values exactly like we did before. Then what we need to do is grab the coefficients from the output. So let's grab those guys. Okay, so y hat is going to equal to times this guy times this guy. Now, when you get to these guys, you're going to do in double quote manager times in times this guy in Almost done here.
Don, by the way, you're missing a parentheses after the manager. The close
Oh, I am? Oh, you are right. Thank you for telling me that. Okay. Almost done. And now we have to do a bunch of plus signs here. Plus, 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 plus. So let's put these guys in parentheses. We don't have to. Now, incidentally, people say, well, how do you evaluate these things? Well, the best way I would recommend doing it is, as opposed to worrying about, you know, the odds ratios and stuff, you can just do something like, look, managers have a negative sign, so they're less likely to default on a loan. Salespeople have a positive number, so they're more likely. You know, that's just look at positive and negative. So debt to income ratio has a positive number, therefore it's associated. The higher your debt to income ratio, the more likely you are to default. If you have a missing debt to income ratio, you're more likely to default. So let's just run this guy real fast. Now, if we did this correctly, we should get the same answer. Y hat should be the same answer as P1. Remember when we got Fred over here? He's got, so our Y hat should be the same as P1 if our score program is any good. So let's find out if it is. Proc print data equals, what is it called? Score? Yep. Score observations equals 10. Run. Let's find out. And we got nothing. Uh-oh. What do we got there? Oh, okay. I got a mistake. Sorry about this. Okay, let's try it again. Okay, let's see what we got. Okay, so Y hat and P1 should be the same. Uh-oh. Do they look like they're the same? That's not a rhetorical question. Come on, guys, is this correct or not?
No, they're not the same.
Correct. What did I do wrong? Anybody? Okay. Remember, this is logistic regression. This is the log odds. I got to convert this thing to odds. Remember? Okay. So this is the log of the odds. So what I usually like to do is if you got this, the math is going to be correct, but in the reality, you want this number to not be too big or too small. So I'll usually cap this guy. I'll say something like, if Y hat is greater than 99, then y hat equals 99. And if y hat is less than minus 99, then y hat equals minus 99. Okay, so I make sure it's not going to be too big or too small. Then I'm going to take the exponent of that guy. Y hat equals exponent of the exponent of y hat. And that's going to give me the odds. So let's see if that works. Okay. So is this correct? Are these numbers the same? Anyone? Bueller? Bueller? Anyone?
They have the same signs, at least.
Yeah, okay, good enough. So now that this is odds, I've taken log odds and made it odds. See, this is why we're doing this, that's why you want to test your program, make sure it works. Remember, odds, we got to convert odds into probability. How do you do that? Y hat equals y hat divided by 1 plus y hat. Now this should work, otherwise I screwed up. And we don't want that. So let's see if we got this thing working or not. And 68, 68, 69, 69, 36, 36. They look like they're right, everybody?
Yep.
There you go. Perfect. Now that I know that this is correct, I would want to print var index y hat, because that's what we're going to submit to Kaggle, okay? Is that what I want to submit to Kaggle? No. I want to submit the test data set. So now I would replace this guy with Heloc test is what I think it's called. I hope I even got a Heloc test out there. lr.heloc test. So now that I know that the program works, this is what we're going to submit to Kaggle. So is everybody getting all this, or did I know I ran through this really fast, but I wanted to walk through the process of it. This is how you really build these models. It should turn into a turnkey operation. You print it, fix your missing values. Now, I didn't do some things like look for outliers. I didn't do things like play around with transformations of the data or anything like that. That's what you do, though. I mean, this is quick and dirty, but you see I fixed this guy. Then what did I do? I ran a proc logistic regression. Then I ended up with a score program. So this is kind of the procedure that you're going to follow. You could conceivably take this code as it stands and submit it to Kaggle, and I bet it would probably do pretty good. This is, and then what I would recommend you do is go back into the course shell and take a look at this, because I do talk about other topics throughout, in these videos. And where is it? Right here. And I've got other things, like I use decision trees. I solved some of these guys with Enterprise Miner. Somebody said, now, which of these guys did I have, did I do it with R? Somebody said I did it with R somewhere. Was it in the...
Scroll, it was like September 2016, I thought. So
September 2016. No? Maybe let's try it in, this is Logistic, let's try it in linear. Yep,
There.
look at that. Yeah, I did it all in R there. So if somebody wants to learn how to do this in R, that's, I did some stuff in R there. But look out there, and if you want to know how to do something, I keep these old recordings floating around, and chances are I've done it. I try not to do the same thing over and over again in these sync sessions. I try to, get a whole bunch of other stuff out there. So, like here I talk about trees for imputation. Look, you can even, if you guys want to try something else to grab some bonus points, go out there, and even if you don't use SAS for this, go out there with R and use random forest or gradient boosting or neural networks or something like that. Try some different techniques and see how they perform, and put it in your document, and I'll certainly take a look at it for possibly giving you bonus points. So anyways, this was just a quick overview on how you might solve the home equity line of credit data set. I don't think I cover it very often in this class, so I wanted to at least say, look, it's a really simple problem, and I'm always surprised at how few students actually attempt it. This is, I cranked out a model in less than an hour, okay? And yeah, I've done this before, so maybe I have an advantage, but you guys should be able to do this in a couple hours or less, no problem. And then you submit this thing to Kaggle and you can get yourself some points. But more importantly, I'm not here to try to get you the points. I want you to learn how to build models. And the only way you're going to learn how to build models is by building models. So that's why I'm just constantly pushing you to try new things, because when you walk out of this class, I want it so that when your boss gives you a big, ugly, messy data set with missing values, it doesn't scare you. You're like, I've done this 1,000 times. When you look at it and it's like boring to you, that's when you know that you're good at this. Okay. So, anyways, does anybody have any questions? We raced through tonight's sync session, but I want to make sure that everybody, does anybody have any questions that we have not addressed yet? Chris Ubelis, tell me a question.
I honestly don't have a question.
I was that good tonight, huh?
Yep.
Yeah, I can hear. Geetha, what about you? Any questions? Nothing. Boy, this is a quiet class. Some of my classes, these guys are like, oh, here, I got a chat window question. Let's see, what do I got here? Is SAS Enterprise Minor, let me move my window here. Oh, is SAS Enterprise Guide similar to Enterprise Minor? No. Enterprise Guide is similar only in that it is a GUI interface. Enterprise Guide just writes code for you using, you drag like a print, some kind of a graph node on the screen, and it's just writing like gplot in the background, okay? Enterprise Minor is also writing code in the background, but it's got a lot of highly specialized stuff that's only available inside of Enterprise Minor procedures and what have you. I would say that the difference between the two is this. Both of them do some analytics, both of them do some graphing, both of them do some data prep. Enterprise Guide is typically used by people who don't do a lot of models. It can do some models for you, and it might even be fine for this class. However, it's not. On mute. There we go. So it might be perfectly fine for this course, but in the real world, you would probably not use it for an extensive problem. It doesn't do things like fix missing values for you. It doesn't do things like handle outliers. It doesn't do a lot of the things that Enterprise Minor does. Enterprise Minor is really good at models and pretty good at data prep and not so good at graphing. Enterprise Guide is great at graphing, pretty good at data prep, and on models. So they just they go towards different audiences. So does that answer your question? If you're going to build models, you really want to learn Enterprise Minor. That would be the one you want. Okay, so I guess at this point, what we're going to do is I'm just going to call it a night on Predict 411, and we're going to open up the show and tell. So I'm going to stop sharing, and I'm going to stop the recording, then I'll start.